Welcome back to All Rounders. So, guys, in this last implementation video, I'll be implementing exception handling in Python along with modules and packages. So, guys, in Python, what is an exception? So, apart from syntax errors and compile time errors, there are certain errors which are not recognized by the interpreter during compile time. They are being recognized at the runtime. They occur at the runtime. So, these are exceptions. So, guys, there are multiple exceptions that are there already in Python, such as name error, type error, value error, zero division error, index out of bound error. So there are multiple exceptions out there. You can create your own exceptions. You can use the currently existing exceptions out there. So let's try a code over here. So basically, we have already told you about the keywords used in exception handling. So over here, I'm printing the value of x, but I have not declared the value of x, and I'm declaring the statement inside try block, which will actually try this block of code, and if any exception occurs, it will move to the except block. So I have written except, and as it is a name error, I have mentioned name error. This is the keyword, and then after the colon, I'm giving the definition that if this exception is being recognized by the interpreter, what it should print. So basically, it will print variable x is not defined. This definition is basically given by me, and you can also change this. So let's run this code and see what happens. See, when the interpreter was compiling this code, there was no error, but at runtime, as x variable was not defined, so it tried this code, and it recognized an exception called name error, and as I had mentioned, variable x is not defined, so it prints this statement whenever it catches this exception. So that was all about this code. Let's move on. So guys, there's another code as I was talking about zero division error. So let's try this exception. So basically, inside the try block, I'm printing 10 divided by 0, and as we all know, this division is not defined and it will not be happening. And so let's move to the except block. So after the except keyword, I'm writing zero division error, as it is zero division error, and after the colon, I'm printing division not possible. So this is basically the print statement that it will print whenever it catches this exception inside the whole code. So that was the main thing, and I'm using zero division error keyword over here, as over here I am only printing 10 by 0 one time, but if there are multiple tries and multiple cache blocks, and there are 10 to 15 zero division errors happening, then I need to mention every time that except and then the definition. But if I mention zero division error, and inside that I give this general statement division not possible, so every time this exception is being recognized by the interpreter, it will print this statement only. So that was the main reason behind this. I can also remove this zero division error keyword, and it will print division not possible. So that's same. Now let's run. See, it prints zero division error. Sorry, it prints division not possible, as it catches zero division error. So now let's remove this thing and see what happens. See, the same thing it prints. So that was no difference. Let's move on. So guys, in your program, you can use multiple try statements and multiple except statements, and then there's another keyword finally. So what's the use of this keyword? So we have already told you that this keyword basically prints the last statement in the code. Like it doesn't matter if the interpreter recognizes an exception or not. If exception is not occurring, then also it will print the statement, and if it occurs, then also it will print the statement. So basically, it's a default statement that the interpreter prints. So first, the try block, I'm printing x, and x is not defined, so it's an exception. And inside the except block, it prints something went wrong. So basically, it catches an exception and then prints something went wrong. And finally, so after finally keyword, I'm printing the try except is finished. So let's run this code. See, it catches an exception, and after that it moves to the finally block, and it prints the try except is finished. So now let's now declare x and see what happens in case the exception does not occur. So I am declaring x is equal to 10, and let's run this code. See, it prints 10 and it doesn't go inside the except block as the code was correct, and it prints finally block, the try except is finished. That was all about finally keyword. You can try this on your own. Let's move on. So guys, sometimes in your code when you are writing very big programs, then in certain part of the code you know that this will uh, surely raise certain errors or exceptions at runtime. So when you know that these type of uh, exceptions will be raised, or if you have put any constraints on the code, then you know that these type of exceptions will be raised, and you need to print certain statements. Like if you are making an app, and over there you have to use internet, like the user need to use the internet to fetch certain value, and the user uses that app without internet. So basically that value that it has to retrieve from the internet, that value is null. So basically it's an exception in the code. So then the user needs to uh, form an action through the app so that the user gets to know that this type of thing is happening inside the code, or this type of bug is being recognized by the interpreter. So that was all about this concept. So over here I am declaring x is equal to 10 and y is equal to 5. So these are the values. Then I'm writing if y is equal to 0, then I'm raising zero division error. So guys, in this program I'm basically performing division of two numbers, and I know that if one of them, like the denominator is 0, then division is not possible. So that's why I'm raising zero division error, and inside the parenthesis I'm writing only integers are allowed. And after that I'm giving else print x divided by y. So that was all about this code. So now let's run it. So in the first case, y was 5, so division was possible. Now let's change y to 0. Okay. So now I have changed y to 0, and now it raises zero division error, and it prints only integers allowed. Okay. And it would have raised the same error if I had not mentioned it, but at that time the runtime would have been more, and now I've already told the interpreter that I have to raise this error whenever the value of y is equal to 0. So that was all about this code, and that was all about exception handling. You can practice as much as possible, and you can use these keywords try, accept, and finally according to your needs, and you can try nested exception handling as well. So all the best, guys, and yeah, let's move on. So guys, now let's talk about packages and modules. So in modular programming, packages are a network of different modules, interrelated modules, and inside modules you can have many functions, many interrelated classes, and you can import certain functions from different modules inside the same package and do abstraction of data and all of that. So now for now I've created a folder named package. Inside this parent folder, there are three Python files. The first one is mandatory, so that Python consider this folder as a package. That mandatory file name is init.py, and this file is empty. Okay, this is mandatory for every package. Now I have created a module named M1. Now let's see what is there in this module. This is a simple Python file m1.py, and in this module I have defined a function addition which basically takes two parameters n1 and n2, and it returns their sum. So that was really simple. Now there's another module which is related to this first module. That's why I have placed these two modules inside the same package. This is the main concept behind creating a package. So now in this module, I'm importing module 1, that is M1. Then I'm taking two variables from the user, number 1 and number 2, and I'm performing addition operation on them by using M1 dot addition. That is the addition function inside the M1 package. So I'm writing M1 dot addition. So if I had to write just addition over here, so to actually remove this extra line of M1 and the dot operator. Then, while writing the import line, you should write from M1 import addition. So that's the line for importing certain particular functions from that module. But now, to make it more simple, I have imported the whole module itself. And whenever you want to, and whenever you are importing the whole module and inside the code you are using certain functions of that module, then you need to mention the module name and the dot operator and then the function name. So that was all. Now let's see by running this module. Now it's asking for number 10, number 2, let's say 20, the answer will be 30. So that was all about modules and packages. If you want to make this module as a wheel, then you need to uh, have setup.py file as well. And after that, then you can install this package on any device by using the pip command. And for that, you can uh, create a subfolder with the same name as the package name, and inside that subfolder you can place these files init m1 and m2, and inside the main parent folder you can put that setup.py file that we had told you in the video, the theoretical video, and you can refer to that if you want to create a wheel. And a wheel is a more uh, refined version of a package. And that was all about modules and packages. And with this, we end our Python series. If you have any doubts regarding this tutorial, you can mail us at thejballrounders at gmail.com. That the mail ID is the mail ID has been mentioned in the about section of our channel. So stay tuned, guys, for upcoming videos. And yeah, keep supporting us.